Hi everybody. We are going to look at some data again today and other ways to represent that data graphically. So we saw in the previous lesson how we can create dot plots and box and whisker plots to display what we call univariate data because it has one variable that we're plotting. So the things that we use today to represent data are used because the data is bivariate, which means there are two variables that we're looking at. So that's kind of how I'm breaking up these two lessons. So the first way we are going to look at how to represent bivariate data is using something called a histogram. So a histogram is a visual representation of data from a frequency table. A histogram is a special type of bar graph in which the height of each bar represents the frequency of the interval indicated. You usually use a histogram to represent data organized by intervals. So I think it's really important for us to talk about the difference between a histogram and a bar graph. So with bar graphs, the things that you are plotting, I guess you can say, are not intervals. So for example, if I surveyed the class and asked, what pets people had, my bars might be labeled cat, dog, fish, rabbit, and so on. And then I would make my bars go to the height of, however many people said they have a dog, however many people said they had a cat, and so on. Another thing with bar graphs is you usually see there's a space between the bars on a bar graph. And that's just because your bars are, again, representing things or single numbers versus in a histogram, your bars are representing intervals, which means like if I said, how many pets do you have? I might have an interval that says 0 to 2, 3 to 5, 6 to 9, and so on. So my bars, because they're intervals, are going to be touching. There's going to be no space in between, just as there's no space in between those intervals. So really when you're looking at, is this a bar graph or is it a histogram? Those are kind of the two things to look for. Are your bars being represented by intervals and are the bars touching? Okay, so let's look at this first example and we can see how we're going to create a histogram. So it says Mrs. Davis gave a 10-point quiz to her 9th grade math classes. A total of 50 students took the quiz. Mrs. Davis scored the quizzes and listed the scores alphabetically as follows. Okay, so we have first period math, second period math, and third period math. And our job is to create what we call a frequency table. It says in part A, use the quiz data to make a frequency table with intervals. And it says to use an interval of 2. So what that means is that we are going to use in our score column here intervals of 2. So if you look, our lowest score is a 1 and our highest score is a 10. So when we do our intervals, we're going to start at 1. And because it says we're using an interval of 2, that means I should have 2 scores within each interval. So 1 to 2. And then my next interval would be a score of 3 to 4. And then 5 to 6, 7 to 8, and 9 to 10. Okay, so our job now, and this is a little bit tedious, but we have to figure out how many scores fall into each of those intervals. Okay, so we can do this using a tally, whatever's easiest for you. I am going to show this using a tally, and then in my frequency column, I'm going to write how many tally marks I had. Okay, so if you look at first period math, I'm going to look at that first row. So there's going to be 1 in the interval 5 to 6, 1 in 3 to 4, 5, 7, 5. Now I'm looking at row 2, 9, 5, 4, 6, 6, 8, 5, 7, 5, 8, and I'm on the last row of period 1, 1, 8, 7, 10, 9. Okay, now I'm going to go to period 2 and I'm going to continue to add on to my frequencies. So 4, 5, 8, 6, 8, 9, 5, 8, 5, 1, 5, 5, 7, 5, 7. Okay, now I'm on period 3. 9, 8, 10. Ooh, I'm out of room. I'm out of room for 5. I'm gonna go over here. 5, 9. Second row, 7, 8, 9, 8, 5. My last row, 8, 10, 8, 8, 5. Okay, sorry, that was a little confusing because I started running out of room, so I was going backwards here. So now that I've recorded using tallies where all those scores fall, I can see that there are 2 scores that fall in the interval 1 to 2. There are 3 scores that fall in the interval 3 to 4. There are 5, 10, 15, 16, 17, 18 in the interval 5 to 6. 5, 10, 15, 18 again in 7 to 8, and 9 in 9 to 10. Okay, so that's probably the hardest part, not even difficult, just tedious, right? Making sure you're being careful when you record that. So now what we're going to do is we're going to take that data and we're going to create a histogram. Okay, so a couple of things. In a histogram, your frequency should always be your y-axis, okay? And your intervals should always be your x-axis. So what I'm going to do is I'm going to start with my y-axis, and you can write frequency as your label. I'm actually going to put number of students just because it's more specific. So this is how many students scored between whatever interval that I'm giving you. And so going back up here, it looks like I have 2 as my lowest number and 18 is my highest number. So what I'm going to have to do is come up with some kind of a scale that makes me go, I'm just going to say from 0 to 20. So if you look at your graph here, let's see, I'm just going to quickly count. Okay, so there are 20 spaces. So I think what we'll do is we'll just count by ones, but I'm going to write every other just so that I can fit it. And it doesn't look like it's squeezed in there. Okay, so now what we're going to do is we're going to plot our intervals, okay, which I had said those are always going to go on the x-axis. And so because our intervals represent the quiz scores, that's what I'm going to label this. Okay, now what's tricky here is that we started our y-axis at 0, and our quiz scores don't start at 0, okay, they start at 1. So what I'm going to do is, because I want my bars to be equal in width, that's really important, I'm actually going to show a line break here, and we've talked about this before, but I'm going to make a line break there. Now some of you have seen it like that, some of you maybe just go like this, okay, either way. But basically, first we need to figure out how wide we want to make our bars, and then our line break should be that same size. Okay, so I have 1, 2, 3, 4, 5 bars that I need to fit here. And we don't want to make them skinny. We don't want to make them like one space. So I'm going to try and make them 3 spaces. So if I make my line break go to here, and then let's see, I can fit 1 bar, 2, 3, 4, 5 bars. Perfect. So I'm going to make my line break like that. And then I'm going to label, okay, my first bar are people that scored between 1 and 2. Second bar is people that scored between 3 and 4. And then 5 and 6, 7 and 8, 9 and 10. Okay, so from here, what we're going to do is we're just going to plot our bars. So how many people scored between a 1 and a 2? We have 2. So our first bar should go all the way up to 2. Okay, now you don't have to shade your bars in. I usually just go like this just to kind of make it a little easier to read. Okay, and then there were 3 people that scored between a 3 and a 4. So I need this bar to go up to 3. And then we had 18 people score between 5 and 6. So our next bar has to go up to 18. Ooh, wish I had a ruler. Okay, so let's shade that. And then our next interval is also 18. So there are 18 people that scored between a 7 and an 8. So same size bar there. Okay, and then our last interval had 9 people scoring between 9 and 10. So our last bar is going to be right there. Okay. Now sometimes you'll see people write right on top of the bars here, like how many or what the number's going up to. A lot of times you do that if like it's not as clear, you know, what your bar is going up to, or if you had to really estimate because your scale was so large. But I just wanted to show you that that's another thing that you could do. Okay, so that's a complete histogram. Okay, so bars are touching, your x-axis are intervals, and the y-axis is your frequency. Okay, so let's go ahead and turn to our next type of representation. This is called a cumulative frequency histogram. Okay, so it says a variation of the frequency table is the cumulative frequency table. The graphical display related to a cumulative frequency table is the cumulative frequency histogram. Okay, so it doesn't sound as scary as it, or it is not as scary as it sounds. Basically what we're doing is we are taking our frequencies and we are adding the numbers that came before it. Okay, so in this example it says a survey was conducted to find out how many hours students spent on schoolwork each week. 100 students were interviewed. Represent these data in a cumulative frequency table and histogram. Okay, so we can see that the table has already been created for us, the frequency table. There were 23 students who said they spend between 1 and 5 hours on schoolwork per week. 25 students said between 6 and 10, and so on. So what we're going to do is we're going to actually add a row to this table, and we're going to call it cumulative frequency. And the reason we're going to do this is because we are creating a cumulative frequency histogram, and so these are the numbers that we're going to be plotting, not the frequency. Okay, so I'm just going to kind of add this on here. So the way this works is you are basically going to take the interval that came before and we're going to add it on. Now, I'm going to show you what I mean by that. So in the first interval, 1 to 5 hours, I have 23 people. Well, because that's my first interval, my first cumulative frequency is not going to change. Okay, I'm just going to write this here, 1 to 5. I'm actually going to add this here too because I think this will help. Now, in the next interval, what we're doing is we're including anybody that spent 1 to 10 hours on schoolwork. And so if we're including 1 to 10, that's the first 2 intervals together. So I'm going to actually add 23 plus 25 to get 48. Okay. My next interval is going to include everything up to that point. So it's not 11 to 15 anymore, it's 1 to 15. And so I need to basically add the first 3 intervals together, or you can think of it as 48 plus 18, which is 66. And then we keep going. So the next interval is 16 to 20, so that means from 1 to 20 is the cumulative interval. And I would be adding the first 4 together, or you can do 66 plus 17, which is 83. Okay, the next interval would go from 1 to 25, and 83 plus 10 would be 93. And then the last interval is basically everything. 93 plus 7 is 100. And one way you can tell that you did this correctly is because it says 100 students were interviewed, so your total should have been 100. Okay, so now we have to put this into a cumulative frequency histogram. So the only difference with this histogram is that your bars are going to continuously look taller as you go because you're increasing how many numbers fall within each interval. Okay, but we set it up the exact same way. So why don't we have on our y-axis here, number of students. Okay, and so we have to go all the way from 23 to 100. And so I'm thinking let's go from 0 to 100. And let's see, could we count, I think this was by up to 20 again. So we could count by 5s. So why don't we make this 0, and then I'm just going to skip every other. Again, just so I'm not squeezing in all my numbers here. Okay, and then our x-axis should be hours, number of hours. And just like in the last one, we're not starting our first interval at 0. Our first interval is actually 1 to 5. So we have to, again, try and figure out how we're going to make this fit. So let's just see. We have 1, 2, 3, 4, 5, 6 bars that we have to fit. It looks like I'm going to break my own rule for this one. I'm only going to make my line break be 2 bars wide because I think otherwise, yeah, that will make it a perfect fit. So I'm going to break my own rule for this. So I'm going to make a line break here, and then I'm going to start my intervals. Our first one was 1 to 5. Then we had 1 to 10, 1 to 15, 1 to 20, 1 to 25, and 1 to 30. Okay, so at least we can put them all there. Okay, so how many people were in the 1 to 5 range? 23. So here we go. So this is one where you're going to see me. I'm going to write the numbers on top of my bar because it's really hard to see, you know, when someone's reading this. Is it 23? Is it 22? Is it 24? So it's good just to write it right on there. Okay, and then in the interval of 1 to 10, there were 48 people. And then 1 to 15 is 66. you can see your bars are going to continue to increase in height. That's the characteristic of a cumulative frequency histogram. Next bar is 83. Okay, and then we have 93. We're getting there. And then our last bar is 100. Which again, so your last bar should always end at whatever the total number of people are, whatever it is that you're surveying. Okay, so again, the only difference between a cumulative frequency histogram and a regular histogram is that your bars on a cumulative frequency histogram are going to continually increase because you're always adding the number that came before. Okay, so those are the two types of representations that we needed to learn today. But now what we're going to do is we're going to answer some questions about them. Okay, so let's take a look. There's an example right here. It says the table below shows a cumulative frequency distribution of runners' ages. Okay, so cumulative frequency distribution. So you're going to see all of your intervals start at 20. Okay, so you have this age group and the total. And so it says how many runners are in their 40s. Well, we can't figure that out just by looking because we don't have an interval that shows how many are in their 40s. We have an interval that shows how many are in from 20 to 49, but again, so we have to kind of work backwards in a way. So what I want you to think about is, okay, if there were 8 people in this 20 to 29 age group, and then there's 18 in this 20 to 39 age group, how many would be in your 30 to 39 age group? There must have been 10 because they must have done 8 plus 10 to get 18. Okay, so we can do the same thing for the next interval. Instead of 20 to 49, let's think of this as 40 to 49. So if there were 18 in the previous interval, now there's 25, there must have been 7. Okay, so that's, and we could keep going. I guess I will just to show you. So 50 to 59 would be the next one, and that would have had 6 people in it, 31 minus 25. And then our last interval, 60 to 69, would have had 4 people in it, 35 minus 31. Okay, so that's kind of how you can work backwards to get it back to a regular frequency table. All right, so how many runners are in their 40s? There'd be 7, because we said that there were 7 between 40 and 49. For B, how many runners ran the race? So because, again, this is a cumulative frequency table, this last number here is always going to be your overall total because you're only measuring between the ages of 20 and 69, and so that range encompasses all of the ages. So 35 runners. Okay, so let's look at the next one here, number 4. The cumulative frequency table below shows the number of minutes 31 students spent text messaging on a weekend. Okay, so another cumulative frequency table. All of the intervals are starting at 41. And so what I would recommend doing is maybe over on the side, let's figure out what your intervals were before they were added, because if you look at what we're being asked to do, it says determine which 10-minute interval contains the median and then justify your answer. Okay, so this is a little bit tricky. So I guess let's talk about this first. If there's 31 total people that were surveyed, which person is the median? Okay, so think about that for a second. If you have 31 people lined up, what number person is the middle number? It would be the, think about that. Would it be the 15th or the 16th? It would be the 16th, right? Because you'd have 15 people on one side, 15 people on the other side, and then you'd have one in the middle. So the 16th person is your median. So what our job is to figure out where is the 16th person in these intervals. Okay, so let's, again, work backwards here. So the interval from 41 to 50, they say, is 2. So if I do 51 to 60, that would mean there were 3 people in that interval. Then I could go from 61 to 70, and there would be 5 people in that interval. Again, I'm just subtracting. 5 minus 2 gave me 3. 10 minus 5 gave me 5. Now if I do 71 to 80, that must have been 9, because 19 minus 10. And then the last interval would have been 81 to 90, and that would have had 31 minus 19, which is 12 people. Okay, so again, the median was the 16th person. Maybe I'll write this. We don't want to forget about that first interval. So if I have to find the 16th person, I'm going to go through and say, okay, 2 plus 3 is 5. 5 plus 5 is 10. And then 10 plus 9. So somewhere in this interval is the 16th person, right? Because it goes from basically the 11th person, right, all the way up. So the 10-minute interval that contains the median, and then we have to justify our choice. So let's write this out. So I'm going to say if there were 31 students, the 16th student represents the median. And I'm going to say 41 to 80 is the cumulative interval. So 71 to 80 is the 10-minute interval that contains the median. Okay, so you guys also could have seen that using your cumulative frequency table, because right here, if I started adding these, 2 plus 5 is 7, right? And I went through, I'm just trying to see here, this interval here where you see 19 people, that has your median also. Okay, all right, let's look over at number 5. So it says the following cumulative frequency histogram shows the distances swimmers completed in a recent swim test. Okay, so it's another cumulative, and all of your distances are starting at 50 yards. So it says, based on the cumulative frequency histogram, determine the number of swimmers who swam between 200 and 249 yards. Determine the number of swimmers who swam between 150 and 199 yards. And then determine the number of swimmers who took the swim test. Okay, so we have a lot of things going on here. The first thing I would recommend is let's go ahead and make an interval, a frequency table with a regular interval, not a cumulative interval. So I'm actually going to just quickly write down that table, because that will help us answer the first two questions. Okay, so our first interval would be 50 to 99. And then the second one would not be 50 to 149. Now it would be 100 to 149. And then it would be 150 to 199. So I'm just using the intervals that they have on the histogram, but I'm making them non-cumulative anymore. So then we'd have 200 to 249 and 250 to 299. Okay, so now let's look. It shows that the interval from 50 to 99 has 7 people, 7 swimmers. The next one has 12, and so that means that there must have been 5 in this second interval. The next one is also 12, which means there were 0 in the next interval. Then it goes up to 15, which means there were 3 in this interval. And then it goes up to 20, which means there were 5 in this last interval. Okay, so the first part says, determine the number of swimmers who swam between 200 and 249 yards. Okay, so using our table, we can see that there's 3 swimmers. And then it says, determine the number of swimmers who swam between 150 and 199 yards. And that would be 0, according to our table. And the last part, determine the number of swimmers who took the swim test. Okay, well, since this was a cumulative frequency histogram, our number up here represents the total number. We could have also added our frequencies from the table that we made. 7 plus 5 plus 3 plus 5 is 20. Okay, awesome. We have one more question about histograms. So the diagram below shows a cumulative frequency histogram of the students' test scores in Miss Guido's algebra class. Okay, so all of our score intervals are starting at 41. And so my guess is that we're probably going to be asked, determine the total number of students in the class, so that we can get right away. But then determine how many students scored higher than 70 and state which 10-point interval contains the median and state which 10-point intervals contain the same frequency. Okay. So let's take care of this first question, because determining the total number of students in the class is easy to do when you have a cumulative frequency histogram. So we can see our last bar here goes up to 30, which means there must be 30 students in the class. Okay, then it says, determine how many students scored higher than 70. So from there on, I think let's start getting our table going here. So I'm going to, just like we did in the last one, I'm going to create a regular frequency table. Okay, so 41 to 50, that interval is not changing, but then I want to go 51 to 60, 61 to 70, 71 to 80, 81 to 90, and 91 to 100. Okay, so we can see 2 was our first one. This one is 5, which means that there were 3 in 51 to 60. This one is 10, which means there were 5 in 61 to 70. And then if that is 18, there must have been 8 in 71 to 80. And then we have 24 here, which means there was a difference of 6. And then 91 to 100 was 30, so another difference of 6. Okay, so going back to the question again. Determine how many students scored higher than a 70. So higher than a 70 means a 71 to 100. So I'm basically adding my last 3 intervals here, 8 plus 6 plus 6, which is 20. So 20 students. Okay, part C, state which 10-point interval contains the median. Okay, so remember we have a total of 30 students that we're referring to here, and so we have to figure out what is the median student. So if you have 30 students lined up, who's in the middle? Well, because it's an even number, there's going to be 2 in the middle, right? So if you think about that, you know, you're looking at basically like 15 and 16. Those 2 people would be in the middle. So if we start looking at our frequencies here, and I start adding, 2 plus 3 is 5, 5 plus 5 is 10, and 10 plus 8 is 18, which means our median would have to fall in that interval because the 15th and 16th student fall within that interval based on our frequency. So the interval of 71 to 80 contains the median. Okay, and then state which 2 10-point intervals contain the same frequency. So based on our frequency table, the 2 that contain the same frequency are the last 2 intervals, 81 to 90 and 91 to 100. All right, awesome. Now, the last thing we're going to do in this lesson, and I know this is a long lesson, so thanks for sticking with me here. The last thing we're going to talk about is the shape of data. Okay, so this is something that you guys will get into more in later math courses, but it's something that we talked a little bit about last year in 7th grade. So we talked about how sometimes box and whisker plots are symmetrical. We talked about how sometimes dot plots are symmetrical. What we didn't talk about is what it meant if it wasn't symmetrical. Okay, we just called it non-symmetrical, but it's actually called skewed. Okay, so I want you to think about it this way. Wherever your tail end of your data is, that's the way that it's skewed. So if you look at these examples here, this kind of like tail end right here is going left, so that means it's skewed to the left. And then in this one, your tail end is going to the right, so that means it's skewed to the right. Okay, so it's, in my mind, it's a little counterintuitive, but if you can think of where is the tail, that usually helps. So we're going to say for each of the following if it's symmetrical or if it's skewed left or skewed right. Okay, so number 7. Hopefully right away you can see it is not symmetrical, and just based on its shape, the tail is on the right, so we're going to say this is skewed right. Okay, number 8, that looks symmetrical to me. Remember, symmetrical just means if you were to fold it in half, it would be the same on both sides. Number 9, definitely not symmetrical. You can see the tail end is on the left here, so this would be skewed left. Number 10, again, this is not symmetrical, and we can kind of see the shape here. The tail would be on the left, so skewed left. Okay, number 11 has a little typo, so I'm going to go like this. Actually, now that I'm looking at it, it has 2 typos. Sorry, guys. All right, we're just going to cross that one out. I wanted it to be symmetrical. And these should be very obvious. That's why I'm not even bothering with that one. So number 12, if you look, your data is skewed to the right because the tail end is on the right. Okay, so just kind of, you know, something that is important for you to be able to recognize, but you won't have to do anything more with it. Okay, very last thing we are going to talk about today, and it kind of goes along with what I just showed you with the skewing. It's something called standard deviation. Now in 7th grade, you guys learned about mean absolute deviation, which was kind of the preliminary idea of standard deviation. So it's kind of like getting you guys ready to talk about standard deviation. So if you remember from mean absolute deviation last year, it talked about how spread out your data was, okay? The bigger your mean absolute deviation, the more spread out your data was. The smaller the mean absolute deviation, the less spread out your data was. So standard deviation is very similar to that, okay? It's much more complicated to figure out the standard deviation, but the idea is the same. So standard deviation measures the spread of the data from the mean. If the standard deviation is small, it means the numbers are close to the average. If the standard deviation is large, it means the numbers are spread far from the average. Okay, so this lovely formula that you see here is the formula that you can use to calculate the standard deviation. The good news is you will not have to do that because your graphing calculator will do that for you. But if you're curious and you want to try this by hand, I have the steps here that you can do that. So it's super fun. Last year when we did mean absolute deviation, we kind of just took the first two steps. We calculated the mean, we determined the deviation or the difference of each data value from the mean, and then our third step was we found the average of those deviations. So again, this takes it a little bit further. Okay, so this is more accurate. So I'm going to show you in your graphing calculator how to do this. So for example 13, it says 5 people were asked approximately how many hours of TV they watched per week. Their responses were as follows: 6, 4, 6, 7, 8. Find the standard deviation of the data to the nearest hundredth and explain what it tells you. Okay, so we want to know, does this data seem spread apart or does it seem close together? So what you're going to do, turn on your graphing calculators. Mine is going to be loading up here. Okay, so once you are in, I would like you to open up a new document and we are going to add a list. Okay, so just like we did in the previous lesson, we want to do that with this. So new document, add lists and spreadsheet, and then remember we have to label our first column X, so up where it says A, in that cell we're going to put an X, and then we're going to arrow down to cell 1, A1, and we are going to start typing in our numbers. So 6, enter, 4, enter, 6, enter, 7, enter, 8. So you're going to have 5 data values to work with here. Okay, once you have that in, we're going to add a page. So Control Doc adds a page, and we are going to add a calculator page. Okay, so just like we did in the previous lesson, we are going to go into Menu, Statistics, Stat Calculations, and then we want to do one variable statistics, just like we did before. Number of lists, 1. We're just going to hit OK. And then when the next screen pops up, remember you arrow to the right so that our X shows, because that's what we labeled our X1 list. And then hit enter, and you're going to have all the information you need. Now, yesterday when I was explaining this, I was saying how, X bar means the mean, and then I said, oh, don't worry too much about that stuff in between your summation symbols and your 5 statistical measures that you need for the box and whisker plots. So what we are looking for here is we are looking for something called the sample standard deviation. I'm going to write that here. Okay, so the symbol for this you're going to see on your calculator is S, X, and then a bunch of stuff which we don't really care about. Okay, and you're going to see the number there is 1.483239 blah blah blah, and it's saying to round to the nearest hundredth, and so I'm going to round that to 1.48. Now the number that you see under it, this is called the population standard deviation, and that one I would also need to round. Just write this out real quick. So the symbol for that is, looks kind of like that. That is 1.33 if I were to round it. Now they will always tell you which standard deviation you have to find. If they don't tell you, you can just default to the sample standard deviation. So that's what I'm doing here. Okay. The difference is, by the way, if you remember from last year, sample is a part of the population. So if I'm only finding, like we are here, 5 different data values, that's the sample, because the population would have been, you know, many more people. Okay, so sample is just a part of your population. So anyways, long story short, this is the number we're looking for. And then it says to explain what it tells you. So because our standard deviation is fairly small, it tells us that the numbers are close to the average. Okay, so let's write this up. Since the standard deviation is fairly small, I mean, I would say 1.48 is small. It tells us the numbers are close to the average. And I think that's good. I think that's really all you need to know. You know, the number of hours these people watch, if these are the number of hours that people watch TV for, they're pretty consistent. Okay, which you can see just by looking at it. All right, let's do one more. A consumer's organization is planning a study of the various brands of batteries that are available. As part of its planning, it measures lifetime, how long a battery can be used before it must be replaced for each of 6 batteries of a certain brand. Find the standard deviation to the nearest hundredth and explain what it tells you in the context of the problem. Okay, so we're going to have to go back in and create a new list here. So I would go home, and then you are going to start a new document. So we're going to add a new list in spreadsheet. Again, call your first column X, and then you can go ahead and type these numbers in. So 83, 94, okay, so now we have 6 numbers in our list. I'm going to go ahead and add a new page, calculator page. I'm going to go menu, statistics, stat calculations, 1 variable statistics, enter because there's only one list. Call my X1 list X, hit OK, and I should see that my standard deviation, sample standard deviation, is 12.13 to the nearest hundredth. Okay, so based on, you know, what we're talking about here, battery life, you're looking at a deviation from the average of about 12 hours. So I think it's probably safe to say that it's a little bit not as consistent. So I'm going to say the standard deviation tells us that the life of the batteries varies from the average by an average of 12 hours. that might be a little confusing. So I'm not really committed to saying how consistent it is, because 12 hours to me doesn't seem too horrible, but at the same time, some people might think that a 12-hour difference between batteries is not good. So anyways, I'm just explaining it as the standard deviation tells us that your average from the average is 12 hours. Okay, so that's just me explaining. And that's it. So I know that seems tricky. Just remember, you're looking for the smaller number to mean that your data is more consistent. And the bigger the number, the less consistent your data is. All right, guys, good job.